So welcome to the video lecture series on quantitative aptitude. In today's video lecture, we will be learning about the concept of LCM and HCF and its practical implications in real-time scenario. This is Dr. K.N.Sivabalan. Now let us see what is meant by LCM. So LCM is called as a least common multiplier. A least common multiplier in the sense that means you have to identify a common multiplier for one or two numbers, 3 or 4 numbers like that. Now let us see, we will apply a method called as long division method in this case. Now I want to find the LCM of 8, 12 and 16. Okay. Now to find the LCM of 8, 12 and 16, we go for the long division method. So we will just try to divide this 8, 12 and 16 by 2. Okay, we will start from the lowest prime factor. Lowest prime factor is 2 here. So 2, now 8 goes 4 times, 12 goes 6 times and 16 goes 8 times. Now again divide by 2. Now this 4 goes 2 times, 6 goes 3 times and 8 goes 4 times. Now when you just closely observe this, we have 2 and 4. We can divide 2 and 4 by 2, but 3 cannot be divided. So what you have to do is first divide 2 and 4 now. So 2 can be divided by 2, so it results 1, 3 will be left as it is. Now 4 will be divided by, will be resulting in 2. Now again, we will try to divide 2. So what will be having? We will be having 1, 3 and 1. And finally, when we divide this 3 by 3, you will be left out with 1, 1, 1. So finally, you should get 1, 1, 1. Now what you have to do, you have to multiply all these factors. So all these factors has to get multiplied to find the LCM. So what is the factors here? So 2 into 2 into 2 into 2 into 3. So 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16 and 16 into 3 is equal to 48. So the LCM of 8, 12 and 16 is actually called as 48. So this method is called as a long division method. Now there is another way for doing this. Let us assume that we want to find the LCM for 3 and 7. 3 and 7. Now you can see that 3 and 7 do not have any common divisors. In this case, only 1 is the maximum divisor here. So assume that if you have a common divisor as 1, so I will just change the color. Okay. So now LCM 3 and 7, you have a common divisor. So common divisor in this case is 1. So it is, in this case, it is called as 1. So if common divisor is 1, what you have to do is we have to simply multiply the terms. So multiply the terms. What is the terms? 3 and 7 is equal to 21. So the LCM for 3 and 7 is equal to 21. So this can be only applied when a common divisor is 1. Now we want to find the LCM of 5 and 9. 5 and 9. So what is the common divisor between 5 and 9? The common divisor between 5 and 9 is actually 1. So what you have to do is 5 into 9 is equal to 45. So there is not any common divisor apart from 1. So we have to simply multiply that answer. So 5 into 9 is 45 is called as an LCM. Now this not only applies for this 2 numbers, we can apply for 3 numbers also. So LCM of 3, LCM of 4 and LCM of 7. Now when you closely observe this, 3 and 4 have a common divisor called as 1 and 4 and 7 again common divisor is 1. So there is none other than only a common divisor called as 1 is here. So we will multiply that 3 into 4 into 7. Okay. So 3 4s are 12 and 12 into 7 is equal to 84. So LCM of 3, 4, 7 is actually called as 84. So this is called as long division method. In long division method, if your long division method is not applied, you can say just try to find a factor, common factor, whether the common factor is 1. If the common factor is 1, simply multiply the terms. So that is called as LCM concept. Now we will go for another problem in common devices. Okay. Now let us say find the LCM of 15, 18 and we will have 21. Now how to find the LCM of this? Find the common divisor here. So make a long division. So 15, 18 and 21. Now all are divisible by 3. Now initially we check for 2, but 2 is not applicable for everything, so we will try to divide by 3. So 3 means it goes 5 times, this goes 6 times and this goes 7 times. Okay. Now only closely observe this, you cannot do anything. So first divide it by 5. So it will be 1, remainder is 6 and 7. Then divide by 6. So 1, 1 and 7, and finally divide by 7. So answer is 1, 1, 1. So what we will do is we try to multiply everything. So 3 into 5. So 3 into 5 into 6 into 7. Okay. So 3 5s are 15. 15 into 6 is 90. 90 into 7 is 830. 90 into 7. 90 into 7 is 830 here. Okay. Sorry, 90 into 7 is actually 630. So the answer is here, it's called as 630. So LCM of 15, 18 and 21 is actually 630. So that is the answer of this. Now we'll go for the next one. Long division method we have done. Now what is meant by the shortcut LCM? Let us assume that. So for very big numbers you have to go for long division, but very small numbers there is always a method to do it. Let us assume that we want to find the LCM of 7, 14 and 21. Okay. Now I want to find the LCM of 7, 14 and 21. What we will do is we will take the biggest number here. So what is the biggest number here? 21 is called as the biggest number. We will check it out whether 21 is divisible by 14. No, it is not divisible by 14. But 21 is divisible by 7. So what you have to do? When you take a biggest number, the rest of the numbers should be dividing that biggest number. Then obviously that is called as an LCM. Now 21 is not divisible by 14. So what we will do is we will make this 21 2 times. So 21 into 2 is equal to 42. Okay, now when you take this 42 is divisible by 14 and this 42 will be divisible by 7. So the LCM of 7, 14 and 21 is equal to 42. So that is the answer. Now we will take another example also. So we can say tons of examples we can apply here. Now the LCM of 6, 10 and 12. Okay, what is the LCM of this? Now the biggest number is actually 12. Okay, but 12 is not divisible by 10, it is divisible by 6. Now we make 12 2 times. So 12 into 2 is equal to 24. Now when you take 24 is not divisible by 10, but it is divisible by 6. Now we will make 3 times. 12 into 3 is equal to 36. So 36 is again not divisible by 10. Now what we will make it? 12 into 4, it is equal to 48. 48 is not divisible by 10. Now finally we will make 12 into 5 is equal to 60. Now when you take this 60 is divisible by 10, it is divisible by 6. So LCM of 6, 10 and 12 is actually called as 60. Okay, so this is called as a shortcut method. So shortcut method can be applied only when the number is very small. When the number is very big, then it's better to go for the long division method. So that's how it functions. We will solve one more problem related to this. So LCM of 5, 10 and 15. Okay. Now when you take this 15, when you take the biggest number is 15, 15 is not divisible by 10. So we will make 2 times of 15. So 15 into 2 is 30. Now 30 is divisible by 10 and 30 is divisible by 5. So the LCM is actually called as, obviously it is called as 30. Okay, so that's how it continues. Now we'll go for the next one, HCF long division method. Now what is meant by HCF? So you have to identify the highest common factor. So what is the highest common factor here in this case? Now let us assume that we take a highest common factor here. So the HCF of, want to find the HCF of 12, 16. 12 and 16. So how to find the HCF of? We will go for the long division method. So 12 and 16, we try to divide by 2. So we will just initially take the smallest value 2. So when you 2 divides 12, the answer will be, remainder quotient will be 6, and 16 you will get 8 as a quotient. Again this 6 and 8 can be divisible by 2. Now you will get 3 here and you will get 4 here. Now when you go for 3 and 4, there is not any common divisor except 1. Now we have to leave as it is. So when you are not able to find any common divisor between two numbers, then obviously we have to leave that. Now what is the HCF now? Now 2 into 2 is called as HCF. So the answer is 2 into 2 is equal to 4. The HCF of 12 and 16 is actually called as 4. Now we take another example also. So we try to find the HCF of, okay. So HCF of 7, 14 and 28. Okay. Now when you closely observe this, we just make a long division method, 7, 14 and 28. So what is the common value which divides this? 2 cannot divide, 3 cannot divide, 5 cannot divide, but when you go for 7, it is divisible. Okay, 7, it goes 1 time, it goes 2 times, 14 goes 2 times, and 28 goes 4 times. Now when you closely observe this 1, 2 and 4, there is not any common term except 1. Okay, so there is not any common term between 1, 2 and 4 except 1. So the HCF is actually called as 7. So HCF of 7, 14 and 28 is obviously called as 7. So we will take another example here. We will take another example. Let us take something like this. So I want to find the HCF of 42, 50 and 56. Okay. Now just take 42, make long division here, 50 and 56. Now all will be divisible by 2. So this goes 21 times, this goes 25 times, and this goes 28 times. Okay. When we deeply observe this 21, 25 and 28, we don't have any common divisors here. Okay. Now the common divisor in this case is only 1 here. So if that is the case, now we have to leave as it is. Now the HCF of 42, 50 and 56 is called as 2. We will take one more example. So we get 24, 36 and 48. Okay. So now divided by 2, 12 times, it goes 18 times, and this goes 24 times. Now again divided by 2, so this goes 6 times, this goes 9 times, and this goes 12 times. Okay. Now when you try to divide it by 2, we cannot divide it, but we go for 3. So 3, 6 goes 2 times, 9 goes 3 times, and this goes 4 times. Now that's it. Now 2, 3, 4. You cannot find any common term here. So the common term is only 1. So what you have to do? We have to multiply this, all these things. So 2, 2 and 3. Okay, 2, 2 and 3 will be giving me the HCF. So 2 into 2 into 3 is equivalent to 4. 4 into 3 is equal to 12. Okay. So HCF of 24, 36 and 48 is equal to 12. So that is the answer for this. Now, we will go for a factorization method. So, what is meant by factorization method? So, I will also go for LCM here. I will go for HCF, then I will go for LCM. Okay. Now, what is a factorization method? So, if I want to find the HCF of, so HCF of 2 power 3 into 5 power 2, comma 2 power 2 into 5 power 4 into 2 power 6 into 7 power 1. Now, I want to find the HCF of all these things. So, if the number is actually given as a whole number, then you know how to find the HCF. But if number is given in the form of factors, what you have to do? So, find how to find the HCF. Now, you take the common term available. So, common term available, so the common term available in this case is, just check this three terms. What is the term which is available common to all this one? 2 is available. So, 2 is actually common to all this. Okay. Now, apart from 2, there is not anything called as common. 5 is actually available, it is 2, it is available in 2 terms, but in the third term it is unavailable. Now, out of this common terms, you take the minimum value here. So, 2 is common. So, what is 2 power here? 2 to the power of 3, and 2 to the power of 2 is there, and 2 to the power of 6. Okay. Now, common term is 2, and we have 3 powers, 3, 2 to the power of 2 and 2 to the power of 6. You always take the lowest power here. So, that means 2 squared. Okay. So, 2 squared is called as 4. So, the value for this HCF for this 3 terms is actually 4. Now, we will go for another problem. Let us assume that I have a problem like this. 3 squared into 5 squared. I want to find the HCF of 3 squared, 5 squared. 3 to the power of 1 into 7 to the power of 1 into 5 to the power of 1. Okay. And then 3 to the power of 3 into 7 to the power of 2 into 5 to the power of 4. Okay. Now, I want to find the HCF of all these things. Okay. Now, in this case, you take what is a common term here? 3, 3 and 3. 3 is common in all these 3 terms. Now, what is the next common term? 5 is common. 5 is common. So, now 3 and 5 are common. Now, what is the minimum term for 3 here? Minimum term for 3 is actually called as 3 to the power of 1. So, 3 to the power of 1 into. Now, the minimum term for 5 is actually 5 to the power of 1. So, 5 to the power of 1. So, now in this case 3 into 1 and 5. So, the answer is 15. So, the HCF in this case is equal to 15 for this term. So, that is called as HCF long division method. Now, if the same case has been asked for LCM, how will you do? Let us assume that I want to find the LCM for factors. So, find the LCM for 2 to the power of 3 into 7 to the power of 1 into 5 to the power of 2, comma. Okay. So, 2 to the power of 2 into 5 to the power of 1, and then 3 to the power of 1 into 5 to the power of 1. So, let us assume that I want to find the LCM of this. Now, you should not see what is the common term here. You should actually pick all the terms, whatever which is available. So, what are the terms which is available? 2 is available, 3 is available, 5 is available, and 7 is available. Okay. Now, what is the maximum term for 2 here? Maximum term for 2 is actually 3. So, 2 to the power of 3 is called as a maximum term. Now when you come for 3, what is the maximum term? Only 1 is available. 3 is only one time it is available. So it is 3 to the power of 1. So when you come for 5 maximum term is 5 square. So here. And when you come for 7, there is only one term for 7. So it's 7 to the power of 1. So what you have to do is you have to multiply everything. So 2 to the power of 3 into 3 to the power of 1 into 5 squared into 7 to the power of 1. So we can abbreviate it. 2 to the power of 3 is 8. 8 into 3 is 5 squared is 25. So 25 into 7. So that will be the answer here. Now you know that 8 into 3 is 24 and 24 into 25 is 600. 600 into 7 is 4200. So the LCM in this case is called as 4200. Okay. So the answer is 4200. I hope that you will be able to get it now. So we will work on one more example in this case. One more example. Okay. So the LCM of 2 to the power of 2 into 3 to the power of 1 into 5 to the power of 2 and 2 to the power of 1 into 3 to the power of 1 into 2 to the power of 2 into 5 to the power of 1. Okay. Now I want to find the LCM of. So what are the terms which is available here? So 2 is available, 3 is available and 5 is available. Now what is the maximum term for 2? So if you want to find the LCM, you have to always take the maximum term. So 2 has the maximum term of 2 squared. So it is 2 squared. Now 3 has the maximum term of 3 to the power of 1 and 5 has the maximum term of 5 squared. So what will be the answer? So 2 squared into 3 to the power of 1 into 5 squared. 2 squared is 4, 3 to the power of 1 is 3, 5 squared is 25. Now you can know that 4 into 25 is 100, 100 into 3 is 300. So the answer is 300 is an LCM for this. Okay. So that's about this concept. So